So let us discuss about technology life cycle. Assume that in technology forecasting, the clear vision about technology life cycle allow us to get necessary knowledge and necessary information to take strategic decision. But before discussing about technology life cycle, let us just recall how do we define technology. If you look to the information technology that we use, for instance, laptop, and we have to have a knowledge in order to use laptop. Without those knowledge, this is just piece of plastic and silicon that can be even not switched on if we have no knowledge how to switch it on and how to operate it. But it is not enough just to have a knowledge how to use a laptop. We have to also have some regulations. We have to, we usually, when we install some software, we sign a license, we have to follow the rules, we have to have internet in order to be connected, and so on and so that. So usually when we look to the technology, we consider technology as a summary of these three main components. The first component, this is artifact. The artifact, usually this is a purposefully designed and manufactured object. Or it can be named hardware because it is a hard, something hard. But without knowledge and skills to design this hardware, to manufacture, to deliver, and to use this hardware, we have no technology. At least we have to have a knowledge and skills how to use this stuff, this artifact. Otherwise, somebody without this knowledge can use the laptop like support for the coffee. It can be also used like that. But it is not enough in order to have a running technology. For a running technology, we also have to use to have institutional settings and rules for generation of technological knowledge and for use of technologies. Because without the standards, without regulations, no technology can be installed on the market. No technology can be really become innovation. It means something which is in regular production, something which has a market. So when we predict technological future, when we talking about technology life cycle, we are talking about life cycle not only of artifact, but we are talking about life cycle of also knowledge and also rules. If you just make a short recall of history, at the beginning of 20th centuries, we had some technical systems for instance, when we had a transportation means not with internal combustion engine, but with the animals, we had one kind of rules on the road regulation. Today, those rules are obsolete. Today, the driver of the car, he or she does not need to have knowledge how to manage a vehicle which is driven by animals. Okay, those knowledge and skills are obsolete today. And those artifacts are obsolete also. We need to understand that technology life cycle, it's not only life cycle of artifact or hardware, this is also life cycle altogether. So for us, in order of this course, technology, this is also, this is always synergy of three components: artifact, knowledge and skills, and settings and rules, which we use in order to operate our technology. Let us see from point of view of life cycle, how in a time things changing. The very basic and very generic concept that everything which has a birth pass through the stage of growth, maturity, decline, and death. Whatever we can observe, whatever we can see, perceive, and discuss always pass through this cycle. We are talking about artifacts, we are talking about ideas, we are talking about regulations. They all pass through this cycle, which can be depicted with this bell-shaped curve. When on the horizontal dimension, we have a time dimension. For different systems, this time is different. And that is why when we forecast, in fact, we need to forecast when and where our technology will pass through which phase of its evolution. The life cycle or cycle of the life of any technology lets us use this simple but very powerful model in order to discuss about life cycle, in order to better understand how can we predict the life cycle and how can we get knowledge and which stage we are. Because if we know at which stage we are with our system, we can know what is necessary to do next from tactical point of view, from operational point of view, and of course from strategic point of view. This is a matter of our discussion. But this bell-shaped curve can be enriched if we will use a concept which is an S-shaped curve, which represents the level of accomplishment. The bell-shaped curve shows the rate of the changes. For instance, how many bicycles per month was produced, or how many bicycles per year was produced, or what is the rate we are witnessing now, very specific situation with the pandemic, and how many cases per day, new cases per day we have. But the S curve, which is on this slide, is a red one, the level of accomplishment. This is a cumulative number. Cumulative number. For instance, if you are talking about new cases per day, the S curve will describe the cumulative number of the cases if you are talking about COVID pandemic situation for different countries. But let us, in order to better understand the life cycle, let us use a metaphor of seasons. And if we just will use the metaphor of 4 seasons, like winter, spring, summer, and autumn, we can see that through its life cycle, any technology passes through 4 seasons. At the birth, we have very low potential of the system. After that, it starts to grow, and level of accomplishment start to grow. In a spring and in a summer, we arrive to the maturity of the system, which on the level of the S-curve, this is a midterm of growth. Later in our course, we will look to the logistic S-curve more in detail, and we will use it for a quantitative study of life cycle of technology. Now, let us understand from qualitative point of view what happens. In the autumn, our systems stop to grow exponentially and arrive to the plateau. When in the next winter, our system does not grow anymore as it was in the growth period, and the level of accomplishment almost not changing. We arrive to the upper limit of growth of the particular system or particular technology. What is interesting to see from strategic point of view, we are doing different things on different stage of evolution, because the transition from the winter to spring, this is a time for research and development and replacement. The new system replaces old one. For instance, today we are listening more and more music by streaming, by downloading, and less on the CD-ROM. This is exactly what happened years ago. The CD-ROM were replaced by new technology with new skills and with new regulations. Nowadays, technology, different markets are growing very fast. And this is a time of maximum rate of output. This is a time when we benefit from our technology most. We have a most rate of productivity, we have a most rate of efficiency. And when we arrive to the autumn, we start to think about what will be the next system to replace. And when we arrive to the winter, this is a time of selection of the best fit for the replacement. In fact, when we make technology forecasting, which has the most demand, especially when company with its business or technology arrive to the autumn, usually the decision makers, they start to be interested about strategic technology forecasting because they need to launch the replacement. And we need to prepare everything for our selection in order to restart this cycle. On this slide, it is presented like from the beginning to the end, but in fact, you can see this is a cycle. This is a cycle like cycle of the seasons. Okay, the new system will start to grow, and this wavy curve just shows that at the end and at the beginning of the evolution of any technology, due to the competition, we have a kind of wavy curve, not so straight. When within an exponential growth, using S-curve is within a time of growth, maturity, and start to decline, the line of evolution of our technology can be expressed pretty clear as a line.